this video, we're going back to basics to show you the fretboard in a new way that will help you reduce the amount of memorization needed to learn new scales, arpeggios, and chords. And along the way, we'll touch on the circle of fifths. One of the guitar's unique strengths compared to other instruments is that any pattern for a scale, chord, or arpeggio can simply be shifted up or down the fretboard to change key. On most other instruments, you'd have to learn 12 different fingerings to master one concept in all possible keys. Shifting up and down the fretboard in this way is easy. Shifting across the fretboard is a little more challenging. Geometric shapes on the fretboard change in ways that aren't always obvious until someone shows you the trick. But learning how to do it can save you a tremendous amount of memorization. There's nothing more fundamental to understanding the guitar than knowing how standard tuning affects the geometry of patterns on the fretboard. In standard tuning, adjacent strings are mostly tuned to be 5 semitones or 5 frets apart in pitch. That's why if you finger the 5th fret of the low E string, it yields the same pitch as the open A string. In the olden times, before the advent of cheap digital tuners, that's how we tuned our guitars. And this strategy works for all adjacent pairs of strings, except between the G string and B string, which are tuned to be 4 semitones apart. This interval is a major third instead of a perfect fourth. At one level, this tuning system makes things needlessly complicated. Geometric patterns on the fretboard seem to get warped when they go across the boundary between the G and B strings. Some guitarists, like Stanley Jordan and Tom Quayle, use all fourths tuning, EAD, GCF, which makes scale patterns much simpler for improvising, at the expense of making many common open chords difficult or impossible to play. And so we ordinary guitarists suffer to understand fretboard geometry so that it's easy for us to strum cowboy chords along to Wonderwall. Yay us! The trick to moving geometric patterns around the fretboard is that any part of a pattern that crosses the invisible line between the G and B strings will be shifted by 1 fret. If the pattern moves from the G string side to the B string side, it shifts 1 fret up toward the bridge. If it moves from the B string side to the G string side, it shifts 1 fret down toward the nut. Let's look at some examples that make this more clear. Here's a major bar chord with its root on the low E string, and here's one with its root on the A string. They look a little different, but they feature the exact same intervals. And as we go back and forth, we can see that the third of the chord is shifting across the G to B boundary. Let's look at how major triads move across the fretboard. From the major bar chord, we can pull out this second inversion major triad and shift it across the fretboard to generate all of the fingerings for second inversion triads. We can do the same thing with the C-shaped bar chord, giving us our root position triads. And finally, we can do this with a G-shaped bar chord, which gives us first inversion triads. Before we apply this to the pentatonic scale, let's take a moment to see how this ties into the circle of fourths and fifths. Here's the chromatic scale arranged in a circle. Since there are 12 chromatic notes that repeat infinitely, it turns out there are only 3 step sizes we can repeatedly take and end up visiting all 12 notes. If we move in steps of 1 semitone, we obviously visit every note. But if we move in steps of 2 semitones, we only visit half of the notes. If we move in steps of 3, we visit 4 of the notes. It's only if we move in steps of 5 semitones, a perfect fourth, or 7 semitones, a perfect fifth, that we end up reaching all 12. Now, if we rearrange the circle into that sequence of notes, we get what's called the circle of fourths and fifths. The name is a little confusing, but it helps to know that a fourth moving up gets you to the same note as a fifth moving down, and vice versa. Moving clockwise moves you up in fourths, and moving counterclockwise moves you down in fourths. There's a lot of music theory we could get into that's based on this, but the main thing to know is that when we shift a pattern up to the next set of strings, we're shifting it up a fourth, or 1 step along the cycle of fourths. If we shift it down a set of strings, we move a step in the other direction. If you memorize the cycle of fourths, B, E, A, D, G, C, F, followed by B flat, E flat, A flat, D flat, G flat, you can easily identify neighboring notes on the fretboard, and this is super useful if you haven't memorized all the notes yet. In fact, you can read out the cycle of fourths as it wraps around the fretboard, as long as you take into consideration the 1 fret shift that happens between the G and B strings and the fact that the 2 outer E strings have the same notes. Okay, Now let's apply this warping to the pentatonic scale and show how you can learn one simple underlying pattern rather than memorize 5 different forms. Most guitarists start by learning the Form 1 pentatonic scale. I'm showing the roots of the minor pentatonic scale in red, but the exact same idea applies to the major pentatonic scale as well. We can shift the pattern up a string, taking the warp into account, and we get a new pattern. If we stayed in the same place on the fretboard, we'd move one step along the cycle of fourths, and an A minor pentatonic scale would become a D minor pentatonic scale. This turns out to be Form 4, and I've shifted it up 7 frets to return it to the original key. If we repeat this process, we get Form 2. Shift a third time, and we get Form 5. Shift one more time, and we get Form 3. If we shift a 5th time, we get back to Form 1 right where we started. Another way of looking at this is to imagine that the fretboard is infinite with all strings tuned in fourths. The 2-note per string pentatonic scale becomes a 5-string repeating pattern, and we can recreate each of the 5 pentatonic forms by selecting a set of 6 strings. To get to a different pattern, just switch to a different set of 6 strings. And if you're not Tom Quayle or Stanley Jordan, just slide the notes on the top 2 strings over by 1 fret to account for the shorter interval between the G and B strings. If you play a 7-string guitar, just pull 7 strings worth of fingerings out of the repeating pattern, shift the top 2 strings as usual, and your fingerings for all 7 strings will fall right into place. We can use this technique to navigate the blues as well. A 12-bar blues progression contains 3 chords that are neighbors on the cycle of fifths. One approach to improvising over a blues progression is to use the minor pentatonic scale and to target the notes of the chords in the progression as they go by. Here's the Form 1 minor pentatonic scale, and here are the notes of the 1 chord overlaid. Note that the thirds shown in blue are flat thirds, so they need to be bent upward somewhere between a quarter and a half step. A lot of the sound of the blues is created by that gray area between the flat third and the natural third. When we shift to the 4 chord, the target notes move up a string, and that flat third that was on the G string shifts up a fret when it crosses to the B string. Then we shift back to the 1 and the target notes return to their original places. When we shift to the 5 chord, the target notes move down a string, and the 5th crosses from the B to the G string and moves down a fret. Let's watch it again, and this time just focus on the thirds in blue. Since these are the most characteristic notes of the blues, they're some of the best notes to target. Just don't forget to give them a little bend. Shift up to the 4, back to the 1, and down to the 5. Okay, that's it for this video. Please like, subscribe, ring the bell, and leave your questions in the comments. And there's more where this came from at fretscience.com.